Well, hello there. I hope if you're watching this video, either you missed when we did this in class, or you just want a little bit of review because, yeah, this is a topic that I taught in class, but I just wanted to make sure to have a video kind of for the record so you could refer back to it. So we're talking about rational exponents here. So the idea is we know a bunch of things about exponents, right? We know 8 squared is 64. We know a negative exponent means reciprocate that. We know a 0 exponent means 8 to the 0 is just 1. We also know how to do some things with square roots and cube roots. For example, I know that the cube root of 8 is 2 because 2 is the number that I can multiply by itself 3 times to give me 8. 2 times 2 times 2 is 8. Therefore, the cube root of 8 is 2 because x cubed 2 is the thing that cubed gives me 8. So the issue is, what happens if I have a fractional exponent? Well, just bear with me for a second here. I'm going to do something, and you may or may not appreciate it, but I know that if I raise both sides, well, let me show you what I'm setting up here. Basically, I don't know what 8 to the 1/3 is, right? So I'll set it equal to x. In other words, I'm trying to find what 8 to the 1/3 is. I know that in order to cancel that 1/3 power, I need to do something that's somewhat opposite of it. So if I raise both sides to the third, let's think about what happens here. The rule of an exponent to an exponent is multiply these two exponents. And 3 times 1/3 is just 1. So if I do this, if I raise both sides to the third power, I'm left with 8 equals x cubed. In other words, I'm doing exactly the same thing I did with the cube root of 8. I'm trying to see what number times itself 3 times gives me 8, and that's 2. So what we're discovering is 8 to the 1/3 is actually exactly the same as the cube root of 8. Likewise, 8 to the 1/2 is exactly the same as the square root of 8, and that would be some decimal answer. What times itself gives me 8. So this is how we deal with fractional exponents. We make them into a root. And here's that definition written mathematically. The exponents as a fraction, whatever's in the denominator of that fraction, make it a root. So let's do some examples. For example, 81 to the 1/2. I know that is the second root of 81. But the second root, what number times itself equals 81, is really just the square root. Square root, we assume the invisible 2. And the square root of 81 is 9. Again, this 2, I could write it, but we know that that just means the square root. 27 to the 1/3. Oh, were you startled by the bell? I was startled by the bell. Usually I don't record at school, but here I am recording at school, and so I have to deal with bells and things. Anyway, 27 to the 1/3 is the same as the cube root of 27. What times itself 3 times gives me 27? Well, if you do 3 times 3 times 3, you happen to get 27. So the answer here is 3. One more example. Ooh, 49 to the negative 1/2. Okay, let's not worry about the negative yet. I know 49 to the 1/2 is the square root of 49, which is 7. So what about 49 to the negative 1/2? Is it negative 7? Well, no, don't forget that a negative exponent means reciprocate. So since 49 to the 1/2 is 7, 49 to the negative 1/2 is 1 over 7, because a negative exponent means reciprocate. One last example, 5th root of 32. Think to yourself, what number times itself 5 times gives me 32, and it happens to be 2. It's very useful to know your powers of 2. 2, 4, 8, 16. The 5th root of 2 happens to be 32. And going on up from there, 64, 128, even 256. It's really important to know the powers of 2. They show up a lot. What about if I have something like this, 27 to the 2/3? Well, let's think about it. I know that 27 to the 1/3 was 3, right? 27 to the 1/3 was 3. And the reason was because 3 times 3 times 3 equals 27. But now I'm not doing 27 to the 1/3. I'm doing 27 to the 2/3. So if I'm doing 27 to the 2/3, doesn't it make sense that I should take 2 of those 3 3s? And 3 times 3 is 9. So 27 to the 2/3 is 9. Here's another way you can think about it. If you don't like this more intuitive way of thinking of it, you can remember that the bottom of the fraction always becomes the root. So what's the cube root of 27? Well, that's 3. But then the top of the fraction is an exponent. So 3 squared is 9. Okay? Here's a mathematical definition of that. If you have a numerator and a denominator in your exponent, remember that the denominator becomes the root, the numerator becomes the exponent. So some examples. 4 to the 3/2. Well, 2 means the square root of 4. And I know the square root of 4 is 2. But I still need to cube that 2. And 2 cubed is 8. Next, 16 to the 3/4. 4 means what is the fourth root of 16? And the fourth root of 16 happens to be 2. 2 times itself 4 times is 16. But I still need to cube that 2. And 2 cubed is 8. Final example, 25 to the -3/2. Okay, so let's just get this right out of the way. I know that the negative is going to mean reciprocate. So let's do 25 to the 3/2, positive 3/2, and then we'll just reciprocate the answer. Remember that over 2 means square root of 25, and the square root of 25 is 5. But then I'm taking the number on top as an exponent. 5 to the 3rd is 125, so the answer is going to be 1 over 125. Nice. Let's do a couple more examples. I can solve equations. For example, let's just divide by 4 right away. That gives me x to the 5th equals 128 divided by 4, I think is 32. To cancel x to the 5th, doesn't it make sense that I should take the 5th root? And the 5th root of 32 is 2. And 2 times itself 5 times, yeah, that's definitely 32. So my answer is correct. Next, to cancel that power of 4, I should probably take the 4th root. Now, I don't know what the 4th root of 21 is, but even though I don't know what the 4th root of 21 is, this is something I can plug into my calculator. Actually, in my calculator, I did 21 to the 1/4, because we know that 21 to the 1/4 is the same as the 4th root of 21. And I got that x minus 3 is equal to 2.14. But isn't it true? Let's think about it. If I had just taken the square root of 21, wouldn't there have been a plus or minus that showed up? And that's because if I'm multiplying an even number of numbers to get 21, I could have a negative or a positive, because if I multiply a negative times a negative, it ends up positive. Same thing with the 4th root. If I have a negative times a negative times a negative times a negative, these two negatives cancel and these two negatives cancel, and that will be positive. So actually both positive 2.14 and negative 2.14 work, which means that when I add 3 to both sides, I'm adding it to the positive 2.14, which is 5.14, and to the negative 2.14, which is 0.86. So I have 2 answers that show up. Why didn't I need to worry about the plus or minus for this one? Well, that's because it was an odd root. And if you have an odd number of negatives, well, the first 2 cancel, the second 2 cancel, but then I am left with a negative. So an odd number of negatives cannot give me a positive, which means I don't need to worry about the plus or minus with the 5th root. All right, that's all we have time for today. Keep in mind that a fractional exponent, so for example, x to the 1/3 means the cube root of x, or something like x to the 2/3 means, hey, take the cube root of x and then square it. Hopefully that helps. See you later.